everyone. So today we're gonna write auto tests. And first we need to check the parity of a number. So this is our first task. I have this file that I created in advance, this class that contains all the methods that we're gonna test today. Alright, so we're gonna start from the method is even. And by the way, sorry for my voice, I'm a little bit sick. So here in the test folder, we have our files that we're gonna test, and here we have the Java folder where I store the methods that I have pre-created here. So we will test the methods from this class, and in order to do this, let's first create a new class which I will call methods test. Alright, so in this class I will create a method that will be executed before each test. So but before that, let's declare a variable of type methods, and let's call it a task. Right, so now I'm gonna put an annotation before each, which will allow me to run the following method before each test. So public void, let's call it pre-setup. And what we're gonna do, we're gonna take this variable task, this field task, and we're gonna create a new we're gonna create an instance of class method. So new methods, so that we would have access to our methods from the class method to test them. Alright, now we're ready to start our first task. So the name of the method is even, so we're gonna check if the number is even. So let's create a new class and call it isEven test. Alright, and we're gonna extend the class that I have already created here, methods test. So this will allow us to, like I said before, execute our pre-setup. So it will be executed before each test. So in order to do this, we need to extend the class methods test. Alright, and now we're ready to start. So first, let's define our goals. So what this method will do is that it will test. It tests if whether a number is even or not. Alright, so we will have positive cases, positive, negative, and corner cases. So for positive, for positive case, we have a number, let's say 4, that should return true. For negative case, we have, let's say, number 3, which is not even, so it should return false. Also we have corner cases, so corner cases, so in case the user enters something like 0, so 0 is also should return true, I think. and we have some negative numbers. So let's say -1, -1. This is of course not even, so it should be false. Alright. Now let's create our first auto test. So it will be void, public void, and the name will be, let's say, user can check if valid number is even. Right. So we can parameterize this test using the annotation parameterized test. Alright, so and here we're gonna pass the parameters. So we call integer initial value. So what we're gonna do, we're gonna declare a variable of type integer, and we'll call it actual value. So let's call it actual result. And here we're gonna test the method is even. So we're gonna use is even, and remember that before each before each method, we have a preset up that creates an instance of class methods, and we can refer to that class using the variable task. So the task dot is even, and we pass the initial value. So initial value. All right. And so what we're gonna do, we're gonna use the assert. So assert true. It should return true. Of course, we need to import this. It should return true if the actual result is true. Right, and now we need to pass the source values for our parameterized test. We can use the annotation value source, and of course we need to import that as well. Value source, and so we pass the ints, right? We need to write ints, then put equal, and within the braces we can pass our values that we want to test. So for positive case we had 4, right? So that I'm gonna mark this with a comment positive case. So this is 4, right? And also we have the corner case for 0. So let's write corner case, and I'm gonna put 0. All right. And of course this should be boolean, not integer, because the return type of this method is even is boolean, and that's why it should be boolean. Alright, now we're good. We can run this test and check. So as you can see, tests passed, so both 4 and 0 are even. Alright, now we can write another method. I'm gonna copy this because it's basically the same for the negative case. So we're gonna rename the name of the method. So user can check if valid number is not even. So is not even. And we should change the assert to false. So assert false, and here we pass 3 as a negative case. So 3 is not even. So So negative, and also we have our corner case -1, which is also odd, and it should return false. So let's say -1. This is our corner case. Alright, and now we're ready to run this. So as you can see, they both passed, and they passed the test. So 3 and -1, they're both are not even. Right, so now we move to the next task. Count the number of vowels in a line. Alright, let's go and create another class. So we create a class and we'll call it count vowels test. So let's create a new class. Echo count vowels vowels test. Right, and the same principle here. We're gonna extend the methods test. So what we're gonna do here is we're gonna test whether so we need to write a test for a method that counts the number of vowels in a string. Alright, and we're gonna use stream for this. So we need to test whether so we have our method count vowels, right? It has an input string, so it takes a string and it returns an integer. So we need to test whether so these are the tests for checking whether a string, whether the string returns correct number of vowels. Right. So again, we have positive cases, negative cases, and corner cases. So for positive case, for positive case, let's say we have the word hello, or let's take my name, let's take Kerim. So this should return 2 because we have two vowels in my name, E and I. So it should return 2. As you know, the return type is integer here. The return type is integer and it should return 2. For negative case, what can we have for a negative case? I mean, there are no negative cases, at least for now, but I have some corner cases. So corner case would be if we have the null string, it should throw the illegal argument argument exception exception, and also what corner case we have? It could be empty string. So empty string should return 0. What else? I think that's it. Let's check. So different strings, null, of course a line without a vowel. So let's say we have something like this. BMW does not have any vowels, so this should return 0. Alright, so let's start from our methods. Let's create public void and say user can how can I call this? User can get count vowels, or user can check user can check valid string for number of vowels. Alright, the long name. So first, what are we gonna do? What do we need for this? We need an input of string. So of course we're gonna parameterize this method as well. So let's pass our parameter string and call it initial string, or we can also say initial value. Let's give it initial string, and then we should have the result of type integer. So integer, let's call it result value. And what we're gonna do, we're gonna use the task and the method count vowels, and we'll pass initial string as an argument for our method count vowels. Alright, then we can use the assert true, and we need to import this. So assert true if the result value is true. Looks like we have a problem. So this is a parameterized test, right? So we're gonna put the annotation parameterized test. Then we need to pass the source value. So we will write the value source, and it has the following syntax. So the values will be strings. So we need to write strings, and then we put equal and the curly braces. So for our first positive case, we have my name, Kerim. So this is a positive case. Positive, or we can say happy path. Alright, then we have the negative, or we can say corner case. Right, so the corner case. corner cases. Let's say corner cases. So this is an empty string. Alright, and also we have the BMW. Alright, and let's remove this one. So now let's run this. So we cannot use assert true for the integer. What can we use instead? Actually, instead of this, we can use another method, which is assert equals alright, and we need to import this. So let's see what we got. We need to compare. In this case we have integer, so integer, expected value, then actual value, and then the message. So our expected value and so for this task specifically, we need to have also the expected value. So we need to remove this. Actually, I need to get rid of the strings, and we need to use method source. So for method source, we need to create another method where we'll store our source values. So it will be public static. We're gonna use stream and with the type arguments. Arguments. Right, and of course we need to import the stream. So, and how we're gonna call this? We're gonna call this method source let's call it valid strings for checking. Alright, then we're gonna return stream of arguments. So arguments dot off. So what was our first argument? It was my name, Kerim. So this is argument, and the expected value and the expected number of vowels for this word is, like we said, 2. Alright, I'm just gonna copy this. So for the BMW we have 0. Alright, and also we have the null, the empty string, which is 0. call this corner cases, and this is a happy path. Alright, so I'm gonna take the name of our method and put it in the method source. Alright, so now we need to pass the parameter names. So the first one is the initial string, and the second one is the integer expected value. And let's keep it let's keep it consistent and use the value instead of string. So initial value, and here I will use initial value. Alright, and now we need to check. So first we have what? The expected one, I guess. Expected, actual, and then the message. So this is actual value. So we have so we compare the expected value with the result value. Alright, now we can run this. And you can see that all the tests have passed. So the return type of the expected value is integer, so these are the integers that we passed, and the initial values are used to check, and the result is stored in the variable result value with the type integer. So two integers are compared, and then you can see that it returned true for all the three test cases. And now I think we have a negative value now, the negative case, sorry, so negative case. Negative case could be when we enter the, let's take my name again, and we will say that this name contains 3 vowels, which is not true. So we can use this for the negative case. And now let me copy this and paste so that we could redefine this. User cannot check string. This is not valid anymore. User cannot check string for number of vowels. So in this case we will create another stream. I will copy this and paste. Let's call it invalid strings for checking. Alright, so we have the null. And we really don't know the value, so I think instead of the stream, I mean, what could null return? I don't know. Maybe 0? Actually, you should throw an exception. Actually, instead of this, let me remove this. And instead of parameterized test, this time we're gonna have just simple test. And what we will do, I will remove the parameters. the result value, we want to check null, and for this one we will use assert throws. So assert throws, we need to import it. So let's see, assert throws, we have the expected type and executable. So expected type is the result value. I mean it should throw the illegal argument exception, and we use dot class to get that one. So this is the expected result, and then we use the lambda expression to have our body. So we take this one and put inside the body. So we want to catch the exception that comes out of this expression. So this expression will throw an exception, and our assert throws, it will catch the illegal argument exception. And in the end we can have a message. Let's say a string, a null string should, or let's say checking the null string should throw an illegal argument exception. I'll just copy this. Right, and then we put the semicolon. Now let's run this test. As you can see, it successfully caught the exception. Alright, I think this is enough for this example. Now let's move to the next task. Line reversal. We need to write a test for a method that reverses a string. Alright, so we have our method reverse that takes string as an input, and if input is null, it returns null. Otherwise, it returns the reversed string. So what we need to do, we need to test the regular lines, empty line, and null line. So let's create a new class, and what we'll call it, we'll call reverse test. So we'll call this reverse test. And we'll extend the class methods test. Alright. So what we need to do, regular lines, empty line, and null. So let's create a method directly this time. I will say public void user can, how we're gonna call this, user can reverse a valid string. And this will be a parameterized method, so we're gonna use parameters. Let's say string initial string Then we're gonna take the task, and the return type of this method is a string. So we'll have string string actual value, and let's call this initial value. Actual value is equal to task dot reverse the initial value, and also we'll have the expected value here that we'll specify in our method source. So expected value and then we'll check assert equals the expected value to the actual value, and now we need to create the annotation. So annotation, this is a parameterized test, and annotation for method source. So let's create the method, or simply we can copy from our previous code. So from our previous code we had the stream. I will just copy this, paste it here. So we have valid strings for, let's call it reversing. So for reversing, and I'll take this name and paste it to the method source. And so what strings do we have? Again, let's take my name and I will reverse it like this. This is the expected value. So Mirek, then we should take the regular lines, empty line and null. So this is a regular line, empty line should be empty as well, and null. Null is for, let's actually define it. So these are the tests for reversing, for checking the reverse values of strings. So for positive case we have my name, so if we input my name, this is the expected result that we should get. Then let's say we have corner cases. Corner cases, so if you have the empty string, then the empty string should be returned. If we have null, I guess in this case it returns null as well, so it should not throw an exception, it should return null, so the expected result is null. Alright, so we can add it to our arguments for the corner case. So we have null and the expected is null. Alright, what else? Null, empty line and regular lines. So I guess that is it. Let's go and run this test. So as you can see, all the tests have passed like we expected, so the values matched. Alright, now let's move the next task. We need to write the test for a method that finds the maximum number in an array. So we have our method findMax, which uses stream. Alright, and we need to test this. So let's go and create a new class that we will call findMaxTest in our code testing package. So findMaxTest. So we extend the class methods test. So what this class will do is that it tests whether these are the tests that will check the maximum number for finding, let's say, for finding maximum value, maximum number in array. Alright, so what do we have? So we have this array. Let me copy this. So this is our array. So the happy path is that our method findMax returns the maximum number. So we pass this array. Right, we pass this array and we obtain 7. Alright, so we obtain 7. This is a happy path. What else do we have? We have a corner case. Corner case. Corner case would be empty array, so something like this. Should throw an exception. Should throw an exception, and let's call it positive pass because we have more examples, positive cases. So in case we have one element in the array, but actually this is more like a corner case. And let's put it in the corner case. So if we have one element, let's say 2, then this should return 2. Alright. For negative numbers, we can put it in positive case. So let's say we have an array of -1. Let's use the same numbers. -3, -5, -7, -2. -2. So the maximum number here will be -2, and it should return -2. So these are the positive cases. Alright. Positive cases with the corner cases. Now let's go and implement the methods. So we'll create public voids. How are we gonna call this? User can find max number using array, using valid array. Alright, so we have the initial value and expected value. So the initial value will be the array itself. So I'm gonna define. So we need to have an array as a parameter. So this is gonna be, this method will be a parameterized test. So we'll put the initial value as of type integer array. So we'll write initial value, and the result of course will be integer because we're finding the maximum number, so it will be integer expected result. Alright, and here inside we'll create a new we'll declare another integer. We'll call it integer actual value or actual result. And remember, we have the task where we can refer to the method find max that we're testing, and within the arguments of this method we will pass the initial value. Alright, and then we're gonna use assert equals because we have our expected result and actual result, so we want to compare the expected result with the actual result. Alright, so as you can see, expected then actual. So now we need to create a method for our parameterized test. So let's first mark this as parameterized test. Then we need to specify the method source. Right, and let's create our method source. So it will be public static stream of arguments, and we'll call this a valid how are we gonna call this? Valid values for checking maximum. Let's say valid values for checking max. Alright, then we return the stream of arguments. So we have arguments of, and now we want to pass the array itself. So in order to do that, we need to use the keyword new integer array, and then we're gonna have our array. So I'll just copy this and put comma. So in this for this array, we expect it to have 7 as a maximum, so I'll put 7. Then I'll copy this, and we have our negative array for the second case. Negative, 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 and we expect in this case to have -2 to be the maximum. So these are the positive cases, so I'll mark them as positive cases. And then we have our corner cases. I will copy this again. Our corner, actually we have only one corner case. The other one is the negative case. So for this one, we're gonna keep only 2 as a single element, and that element should be the maximum because it's the only element in our array. Alright. So now we can copy this name of the method and paste it to the method source, and now we can run this. So all tests have passed, and they are correct. Now we have another one, the exception. So for this one I will create I'll just copy this and I will mark this as the test. We'll remove the initial and expected results. So for this one, user, let's say cannot find maximum number using array. This is invalid array. So I'll get rid of this. Or I could take this initial value I will declare it within the function, so this is empty, or could just take this, I'll get rid of this extra lines and put it inside. So new integer empty array. Right, and the expected result. The expected result is we expect it to have to throw an exception. So actually for this one we'll use assert throws, so we don't need an expected result. Instead of that, we go and say assert throws. So it throws what? Null pointer exception. Let's just say exception. Exception. Exception.class. Alright. And here we'll have our lambda expression. And we need to put this inside the lambda expression. So this one should throw an exception, as we know. no such element exception. I can copy this and we can go and paste it. No such element exception. Alright. Now we can run this. So as you can see, program successfully. The method passed the test because it threw the exception and we caught it. And in case this method does not throw an exception, we can write here a message checking method for throwing no such element exception. No such element exception. Alright, and let's say we put some kind of an arithmetic exception, which is not true. Arithmetic exception, then it should be yellow, and the test failed. Alright, test failed because we were checking the method for throwing no such element exception. Unexpected exception type was thrown. Expected arithmetic, actual no such element exception. So that's why we're gonna keep it no such element. Now everything should work correctly, as you can see. Alright, let's move to the next one. Checking if a year is a leap year. So we need to write a test from test for the method that determines whether a year is a leap year. So we have this method that accepts integer and returns boolean, and we have this function that determines whether the year is leap or not. So we need to include ordinary years, leap years, and years that are divisible by 100 and not by 400. So let's go and create isLeapYearTest class. So we'll create a new class, isLeapYearTest, and we're gonna extend our methods test. Alright, so again let's start from the design. So here we'll have tests for checking whether a year is leap or not. And we have our positive cases. So positive cases as follows. So if we say 2020, so it accepts integer and returns boolean, should be true. Then if we say 2000, should be true. 1600 should also be true. Now we have so if year is divisible by 4, And also when you divide it by 100, there is no remainder, it is a leap year. Or year divisible by 400 is 0. So – 2020 should be a leap year. 2000 also a leap year. No, 2000. Yes, 2000 is a leap year. Alright, so we have our corner cases. Corner cases. Let's say 0, which should be I guess true. Let's say negative 2020. Which is also true. If we say null, I mean if it's empty, actually it cannot be null because we have integer and impossible to have null in a primitive data type. And we have the years 1900 and 2100. So these are not leap years, but they are divisible by 100. So we should check these as well. Let's put them in the negative cases. Am I right? Or I will keep them in positive. I'll just say false. False. 2100 false. Right, so these are the expected results. We will use assert true or assert false. For this one, we will see. So first let's create a method. Public void user can check if valid integer or if valid year, let's say valid integer is leap year. Alright, then we have our integer as initial value. This will be a parameterized test. So again we have the return type boolean. Am I right? The return type is boolean. So boolean expected, actually this is actual result. We'll use task dot isLeapYear. It will pass the initial value. And also we should have the expected value as a boolean. So boolean expected result, let's say. Expected result. So we'll go and say assert true. Assert true, import this. I guess first comes the expected one. guess we don't need the boolean one. Assert true. Actual results. So we know that the actual result should be true, since here we said user can check. So this will be a parameterized test again, so parameterized, and for this one we can use source value source. So we have integers, that's why we'll say ints equal to so we want to pass 2020, 2020, 2000, so these are all true values, 1600, minus 2020 and 0. So I will mark this as a positive cases, and these are corner cases. Alright, we can run this. So, like I guessed, 0 is a leap year, so they all passed the test. Now we're gonna create another one, so I'll just copy this. So user can check if valid integer is not leap year. So for this one we're gonna have this value and this value, 1900 and 2100. So these are the negative cases. Alright. And this should be assert false. Now we can run this. And as you can see, they both passed the test. Now we can move to the next one. Write tests for the method that checks whether a string is a valid email. So we have our method public boolean is valid, which accepts the string, returns boolean, return email. So email should not be null, and it should match. I guess these are all the symbols in English, right? So we should check for null, and we should check for correct and incorrect emails. As you can see, they have this @ sign, then dot sign. So they all must be separated by the @ and dot. This is incorrect one. This is incorrect one. So we'll check these, and for that one let's create a method, the class, and call it isValidEmailTest. So I will call this isValidEmailTest. valid email test. As you can see, these are the regex. So let's go to our valid test email, and again we extend the class methods test because we want to reuse. So let's start from the predefining. So in this section there will be tests for checking whether an email is valid or not. Positive cases, let's say Happy Path. So for Happy Path, we're gonna have this email, this one. So I'll just copy paste it, and this should be true. Alright, then for corner case, or let's say negative, negative cases, we have this bad@.com example. Bad@.com, which is false. This is not a valid email. Then we have no @ symbol, no @ symbol, which is also false. What else? The null value, which is actually a corner case. So if it's a null, then if it's a null, and since we have the string can store null values, I guess. Am I right? String is not a primitive data type, so I guess it will return false. Or it might throw an exception. We'll see. Let's find out. So let's create a new method, public voids. Let's say user can check if valid user can check string, or user can check if valid string is email. Like this. So we'll have our initial values, the string initial value, or initial string, whatever. Then we'll have our expected boolean, actual result. Then we'll call task dot is valid email, and then we'll have our initial string here. Then we'll check assert true, the actual result. So this is a parameterized test, so we need to use annotation. Then we need to specify the value source. The value source will be strings. So strings, the first one is this test example. Actually, let's use this for the negative case, and I will say user cannot check if string is email. So I will copy this one. So bad example. Then we'll have the string with no @ symbol and null. Actually, let me add the empty one. Empty string should also be false. Looks like null is for throws an exception, so we cannot keep null here. It says yes, we cannot have null in this case. So this should be false, assert false. These are all invalid email addresses, so let's go and check this. As you can see, they all pass the test because they are not invalid email addresses. Alright, so I will just copy this one for the happy path. User can check if valid. String is email. I will get rid of this. For the initial string, I will take the test example, and it should be true. And this is a test. So let's go and run this. As you can see, this is a valid email and it passed the test. And one more for the null. I will copy this test. User how we're gonna call this? User cannot check let's call it invalid. User cannot check if invalid string is email. So instead of this, we're gonna have null. So null, and it should throw an exception. So we're gonna use assert throws. Alright, assert throws. What exception will be thrown in this case? Let's see. Let's go over the example. I will just keep the exception. Exception.class. Then we have our lambda expression, and we need to put this inside our lambda to catch that exception. And let's see what we got. It didn't throw an exception. Nothing was thrown. Yes, like I said, string is not a primitive data type. It's a reference type, so it can store null values. So it returned false, most likely. So let's try to add null. I will get rid of this. Let's try it one more time. Element value cannot be a constant expression. Okay. I will take this null and we will change the body of our method, and here I will write checking the result of null string. Alright, so we'll pass null here and it should assert false. Let's run this. As you can see, we expected it to have a null and it turned out to be true. So this is it for this example. Now let's move to the next one. So we have to write a method. We need to write a test for the method that calculates the factorial of a number. So the test should check if 0 factorial is equal to 1, small numbers and negative numbers should throw an exception. Should throw an exception, illegal argument exception. So we will call factorial test. We'll create a new class and call it factorial test, which extends methods test. So again, we start from the designing the problem, describing the problem. So these are the tests for checking whether so these are the tests for checking whether a number can have a factorial. Alright, so for positive cases we have the 0 factorial. So we input integer and it should return the factorial. So if we input 0, we should have the return type is also integer, so we should have 1. Then we're gonna check small numbers, like if we say 1, it should return 1. If we say 5, the factorial of 5, I guess it's 125. I will check. So 5 is 120 and 7 is 5040. So these are the positive cases, I mean the expected results. Let's have a negative case, or let's call it corner case. For the corner case, it will be a negative number. So there are no factorials of negative numbers, so it should throw an exception. Throw illegal argument exception. What else? I guess that is the only corner case. So now we can move on. So let's create public void. Let's go user can check if valid integer, can have factorial. Alright, so this will be a parameterized test. So we have our initial value and expected value, and they are both integers. So I will say integer initial, integer, and integer expected, integer. Alright, and then we'll have our actual result. We'll have our actual integer. So we call task dot factorial, and then we pass our initial integer. Then we go and say assert equals. Assert equals, so first comes the expected, then actual, expected, actual, yes. Now we need to mark this as a parameterized test, and we need to specify the method source. So method source, we're gonna create a stream, public static, stream of arguments, and we will call it valid integers for factorial. And we return stream of arguments. So we have our 0, and we expect to have 1. And then we have 1, and we expect to have 1 again. We have 5, and we expect to have 120, and last one, 7, we expect to have 5040. Alright, so these are the positive cases. I copy the name of the method and paste it to the method source. And now we can run this. So all the tests have passed. And for the corner case, we can write another one. I will just copy this one. User cannot check if integer actually let me make the name of the method clearer. So let's say user can check if valid integer is factorial. So basically we pass the factorial here. So user cannot check if valid, cannot check if integer is factorial. So for this one, we'll have a single case, which is a negative number, and then we will use assert throws. So assert throws illegal argument exception dot class. Then we have our lambda expression, and here comes the expression that we want to throw an exception, and we'll catch it. And let's mark this as a test, so we would have an entry point. And let me write a message. Expected to throw illegal argument exception. And we can go over and see the results. So true, it passed our test. It truly threw an illegal argument exception. So we can move to the next task. Public find second maximum. Alright, let's go and create a class with the name find second max. So new find second max test, and of course we extend the methods test. Then we start from the design. So we want to have tests that check we'll have tests for checking the second maximum number. So for positive, or let's say happy path, we have the array, right? We have the array of numbers. So let me come up with some random array. let's say 2, 3, 1, 5. So the second maximum in this array is 3, as you can see. So I should return 3. So it takes an array and returns integer. So this is a happy path. What else do we have? A corner case. A corner case says if, for example, the array has one number, then it should throw an exception, I guess. Should throw no such element exception. No such element exception. Same for the empty one. An array with identical numbers. So let's say 2, 2, 2, 2, 2. Second maximum will be 2, I guess. So let's go and find out. Public void user can check for second max or let's say user can check if valid array has second max number. So again, we have the initial value as an integer array, so we'll say integer initial value. Then we have the expected result. Expected result. We have the actual result, so integer actual result, which is equal to task dot factorial. Oh, find second max, sorry. Then we pass the initial value. Then we will say assert equals. So assert equals expected one and actual. Yes. Expected and actual. So now we need to put an annotation that this is a parameterized test. Then we'll put another one for the value source. And so actually we need to have a method source for this one. So method source, and let's create a stream. So public static stream of arguments, and we need to import the stream. And how we're gonna call this? We're gonna call valid source. Let's say valid source for finding second max, and we'll return stream of arguments of we have this array, and in order to pass that array, we need to use the keyword new, and then say integer, and then use. Looks like I didn't copy this one. And we expect to have 3 as our second maximum. So let's go and copy this. For the identical ones, we'll have 2, 2, 2. Alright. And I will mark this as happy path. And this one is corner case. And let's take the name of this method and put it in our method source. Now let's run this. For the last one, we got an exception, no value present. So it means that it should throw no such element exception, and we will redefine this one. So let's get rid of this. So in this case, what we can do is that we can pass this one within the initial value and remove all these constructions and have a value source. Value source. We want to have 3. So ints. Can we just keep the 3? No. Now we can run this. Yes. For the corner cases, I will create another method. So we will copy this one. Paste it here. We will have a method source. Method source. User cannot check if array has second maximum number. So for this one, we're gonna have integer initial value. Here we'll have initial value, and we'll remove assert equals. And now we need to create a stream. So public static stream of arguments. Then we'll say invalid values for checking second max. Right, and I will return a stream of arguments of So these are all corner cases. So we have the identical array. Actually, we don't need a stream. We don't need a stream. We can use a value source. Value source, since we pass only one parameter. So value source. So these are the ints. Alright, so these are the ints. And we need to pass the array. Let's say new integer 2222. Is it illegal? Yes, we cannot pass it like this. Actually, yes, actually we need the method source. We cannot have an array in the value source. So I will just keep it back as it was. Say invalid input arrays. We can get rid of the expected value. So we want to have the straight twos. 222. Right, then comma, then we're gonna have a single element and empty array, and we'll take the name of this method and we'll paste it here. Then we're gonna say assert throws. So you should throw the no such element exception. No such element exception. Dot class. Then we have our lambda expression. And we'll take this one and put it inside. Like this. So now we can try this. It should all be correct. Not exactly. This one passed the test. The first one, 222, through the no such element and no such element exception. But the second one we expected to have the illegal argument exception. We expected to have the illegal argument exception because this one throws the illegal one. And the third one, also the illegal argument exception. So how can we fix this? Alright, so we have a minor issue because our invalid input arrays, they throw different exceptions. So that's why we can use the exception in general to catch all of them. So now if we run this, they will all pass the test. And the minor issue in this example, I used parameterized test a lot, so instead of that we can use just test for this one, because we have a single value, and instead of the expected one I'm gonna put the 3. Now we can run this. I just simplified the test, so it's the same test. Alright. Now let's move to the next one. Write tests for method that counts the number of words in a string. So we have let's go and create a new class that we'll call count words test. So new class count words test. That extends methods test, of course. And let's create our methods. So first let's find out what this method is about. So it accepts a string and returns integer. So we'll have to use equals. So it counts words, and we pass a sentence, right? So we need to have an empty line, null line, and a line with multiple spaces. So let's go and create our method. So we'll call public void user can so user can what count words if valid sentence. Alright. If valid sentence, then we'll have our string sentence and the expected result. So the expected result is integer. So integer expected result. Expected result. So what we're gonna do, expected result. Alright, so we're gonna have an actual result, so integer actual result, and then we're gonna use task.count words in the sentence. Alright, then we're gonna take assert equals, and we're gonna compare. We will compare the expected one with the actual one. So this is a parameterized test, and we need to have the method source. So let's create a method source, public static stream of arguments, so we'll say valid sentence has input, and we'll return stream of arguments of. So first we need to have an empty line. So this is the empty line, and we expect it to have 0 words. Then we need to have a null, but it most likely will throw an exception. So I will keep it for the corner case, for the negative case, and some actual sentence. Let's say hello world, and again hello. So 1, 2, 3, 4, 5. So we expect it to have 5 words. In this sentence we have 0, and then in this one we have 5. Alright. And the one for null, since null most likely will throw an exception, I will keep it for another method that I will create later. So we'll copy the name of this method and paste it here. Now I'm gonna run this. So it runs as we expected. Let's also have one more with multiple spaces, the same one, but I will put multiple spaces here, like this. Let's run this one more time. As you can see, it says expected 5, actual 6. Probably it took the comma as another sentence, so just let me remove this one. And now it works correctly. Alright, and the last one we need to check for the null. So I will copy this method and paste it here. This will be a simple test. will say user cannot count words if invalid sentence. So our sentence is null if let's say null sentence. If null sentence, we'll get rid of this since we're gonna use assert throws. So assert throws throws exception dot class. Then we have our lambda. And the actual result is here, so I will just take this and paste it in our lambda. Let's run this. So it passed the test. But I'm curious what exception it threw, so I will just put some random exception to see the actual exception. Null pointer, isn't it? Yes, null pointer. Let's put null pointer here. So I will run this again, and as you can see, it passed the test. So we caught the null pointer exception. Alright, now let's move to the next one. We have checking the validity of the phone number. So I create a test. Is valid phone number test extends methods test and then we have this method and we need to test this. Alright, so we have the correct numbers and incorrect numbers. Let's quickly write. So here we'll have tests for valid tests for checking valid phone numbers, happy path. Oh. So we have happy path. This number is a valid. So this is true. And actually it's a string. So I will take this number. Let's return true. And the corner case cases and this 1 2 3 4 5 false, and something like invalid is also false. Alright, so now we go and create a method, public void user can check if string, if valid string or let's say if phone number is valid. Then we have our initial value as a string, so initial value, let's say, and we have our actual value, which will be boolean, so boolean actual result, let's say, and we go to task dot is valid phone number, and we pass the initial value here. Then we go and say assert true actual results. So this is a test, so we put annotation. Alright, and since we have only one happy path for this, I think we don't need a parameterized test, so I will just copy this for the next one and get rid of the initial value. Instead I will paste this one, and now we can check this. So this is true. Now for the corner case, we're gonna use a parameterized test. So user can check if phone number let's say user cannot or user can check if phone number is not valid. Is not valid. Then we need to have a source, value source. So value source strings. So we have 1, 2, 3, 4, 5. Right, and we have the string invalid. So these are invalid strings, and it should assert false. Now let's run this. As you can see, they both passed the test. So let's move to the next one. We have filtering a list of numbers. So we have a normal list, and a list without even numbers, and empty list. So given that we have a normal list, then it should leave only even ones. Alright, let's go and create a new class which we will call filter even numbers test, which extends the methods test. Alright, so what do we have? We have, what is our methods? Methods. Not this one. here is our filter even numbers method that takes a list and returns a list. So so we'll have tests for filtering even tests for filtering list of numbers, or let's say for converting a list of numbers into a list of even numbers. Yes. So happy path. Happy path would be, given that we have a normal list like this, I will just copy this one, and we obtain something like this. Alright, so this is the happy path. Corner cases. Given that we have an empty list, if we have an empty list, then we should return an empty list, I guess. If we have a list without even numbers, so something like 1, 3, 5, then I guess it should return an empty list. Let's go and find out. So I'll create public void user can filter. Even numbers. User can filter even numbers. So initially we will have a list of numbers with the type integer. So so we have a list of integers as our initial input, so initial list, let's say. Alright, and for the actual one we'll also have a list of integers, since we want to obtain filtered list. As you can see, it returns the list of integers, and then we'll call it actual list or actual result, let's say actual result, which is equal to task dot filtered even numbers, and we pass our initial list. Also, we want to have a list of integers with the expected one, the expected results. Alright, then we will compare them using assert. But actually we don't need, we have only one case, so instead of that we will not use parameters for this one. So we will use new array list. List of this array. Alright. So this is the actual result. Then we'll say assert equals assert equals the expected one is this new array list, list of 2 4 6 4 6 and the actual one, we say actual results. And let's put annotation to indicate that this is a test. What's wrong with this? Now we can run this test and see what we got. So as you can see, it passed the test. So happy path is satisfied. Now we need to check the corner cases. For the corner cases, I will copy this one, paste it here. We'll have parameterized test. Parameterized. I will just go over my previous examples and I will get this stream so that I don't have to write it again. Parameterized, the method source. So we will have valid inputs, valid input arrays. Actually, these are the invalid ones for our corner case, so it will be invalid input arrays. So we have empty one, empty list, So for this one, user cannot filter even numbers. Alright, I will get rid of this assert equals. Actually no. So for the new array list, list of the empty list, we expect to have the identical empty list. Or I'll keep it like this. For the new array list of odd numbers, so there are no even numbers, we expect to have an empty list as well. Alright, so these are all corner cases. Let's try to run this. Actually, user cannot filter even numbers. Then we have invalid input arrays. Then we need to have a list of integers as the initial list integer and list integer expected. Like this. And instead of this one, we will have our initial list, and for the assert equals we'll have expected list. Expected list compared to actual results. Actual list. Let's keep it actual list. Alright, I will run this and see what we got. So as you can see, they both passed the test. In case we have an empty list, it just returns an empty list. If we have a list without even numbers, so in this case I have a list without even numbers, it returned me an empty list. So that's what you see when you run this test. So they both passed the test. Alright, now let's move to the next one. We need to sort a list of strings by length. Let's go and see sort by length. So we'll create a method, we'll create a class, sort by length test, which extends methods test. And the goal here is to have tests that they accept a list of strings and return a list of strings. So it sorts a list by it sorts a list of strings by its length. So if we have 4, 1, and 6, C is the smallest one, so C comes first, then Java is the second smallest, and Python. Alright, so that is the logic. So we will have tests for tests for sorting string, for sorting a list of strings by their length. So happy path would be, in case we have this list and we have this output, so this is the happy path. Then we will have corner cases. Corner cases, if we have the equal lengths, so if we have something like AA, BB, and CC, so these are all equal, I guess the result would be the same. And if we have the empty list, so if we have the empty list, I guess would have an empty list as well as a return. So let's go and create a public void method, and we'll call user can sort valid list by valid list of strings by length. So we'll have a, for first happy path, we will not parameterize it since we have only one path, one input. So I will say test, then we will go and have a list of string, yes, a list of string, and we'll call it actual list. So we'll go to task and sort by length, then we'll have new array list. And we'll pass list dot of Java, C, and Python. So Java, C, and Python. So this is our, this will be our actual list, and we will say assert equals, we will use method assert equals. First we pass the expected one. So if we have a list of strings, okay, objects, first we have the expected one, so I will put actually new array list of C, Java, and Python. This is what we expect. Alright, and our actual list. Let's go and check this. So the result is that's correct. We obtained our expected list. They matched. Now let's create a test for our corner cases. I will just copy I will go to the previous one so that I don't repeat myself, and I will copy this stream because we're gonna need a stream. So I paste the stream, and again we're gonna use assert equals, so I will copy this one. So this will be a parameterized test, and we'll have a method source, which we will call invalid input arrays. Let's keep it like this. And we'll call user can sort. Actually, we could merge this both happy path and corner case into one test. Okay, that's what I will try to do right now. So we will have list of string as our initial list. Then we have list of string as our expected list, and initial list. All right, and the actual list, which will be. So first let me take care of the corner cases. So we have corner case, this one. So new array list of these ones. Sorry for that. So we have our list. So I will paste it here, list of these, and we should obtain the same one, exactly the same list. Then we have the empty one. If we have the empty list, then we should obtain the empty list. Alright, so these are the corner cases, and like I said, I want to merge the happy path as well. So I will take happy path and I will copy this one. So for happy path, what we had this list, so these ones, we should obtain this list. Alright, I will get rid of this one now, we don't need it. So we have our happy path, corner cases, and what's left. Now we need to remove this one, and put our initial list here. And when we compare, we want to have our expected list first, then actual list. Alright, so now we have only one test. Let's go and run this. So they all passed our test, and we got the results that we expected. Alright, let's move to the next one. Checking if a string is an anagram of another. So let's create a class which we will call is anagram test is anagram test. So this method takes two strings, string 1 and string 2, and returns boolean. So what is anagram? Let's see. But first I will extend the class methods test. Then we go and create the design. So here we'll have tests for checking whether two strings are anagrams. Right? So what is anagram? For example, listen and silent, they are anagrams of each other. So happy path would be, if we have strings listen and silent, then it should return true. So anagram is when two words, they contain the same letters. So as you can see, they both have these letters. If we rearrange these letters, then they will be equal to each other. So corner case or let's say negative case first. Negative case. Java and Python, okay? So Java and Python. These are not anagrams, so it should return false. Then for the corner case, null should be false. Null also if we have two empty strings, I think they are anagrams, should be true. What else? I think that those are the all combinations that we can have. So let's go and implement this. Public void user can check if valid strings are anagrams. Alright. So we'll have two strings, string str1 string str2 string. Alright, then we will have boolean actual value, actual result, which is equal to task dot is anagram. So string 1 string 2. Like this. So then we'll use assert true. actual value, actual result. And here we'll use the annotation parameterized test, then we'll use value source, actually method source, because we need to pass two strings. And I will go and copy the stream. So here we have the stream. The name, we can have the same name, valid strings for checking. Then the first argument, listen and silent. So these are our arguments. I'll take them and put here. So this is a happy path. Then we have the corner case for the empty, two empty strings. I guess they should return true. We're gonna check that. Alright, let's run this. So as you can see, they passed the test. Now let me copy this for the another corner case, a negative case. So here we'll have invalid strings for checking, and then we'll have Java and Python as a negative case. And a null string should also return false, so we'll have null and null. User can check if valid strings are not anagrams. And here I should change the assert to false. See, they both passed the test. Right. So let's create a class find average test, which of course extends the class methods test. The purpose of this class is to have tests for, so we have the method find average that takes up an integer of array of integers, an array of type integer, and returns double. So double is its average. So for example, we have this array 1, 2, 3, 4, 5. Then what it does, that it takes all the numbers, adds them, and divides them by the length of the array. So we get 3 in this case. So what we're gonna do is that we're gonna test. We're gonna have tests for checking the average value of an array. Alright, so happy path would be or let's say positive cases. So for positive cases, let's say we have an array we have an array 1, 2, 3, 4, 5. So something like this. And the average would be 3. So this is the value we expect from this array. If we have a single element like 10, but it's more like a corner case, I guess. We expect to have 10. Alright, if we have an empty array, then it should throw an exception. So this is like a corner case. Corner case. So if we have an empty array, then we should get throws exception. Exception. Alright. And this is also a corner case. So this is a happy path. Alright, so let's create a method. Public void. Let's call user can get the average from valid array. From valid integer array. Alright, so what we're gonna have an array of integers. So integer array, we'll call it what? Initial, or let's say some kind of let's call it numbers. And we have expected result, which is double. So double expected result. Right, and then we'll have an actual value, actual result, which we'll store here. We call task find average of numbers. Alright, then we'll say assert true. Actually, let's start from corner case. We'll assert false. False actual results. Actually, no, assert false, because in this case we pass the expected value. The return type is not boolean, the return type is double, so that's why we're going to use the assert equals. Assert equals expected and actual, like this. So this is a parameterized test, so we're going to use the annotation parameterized test, and we'll specify the method source. The method source, again, I'm going to paste here the method stream. We don't need this one. So these are the valid arrays, or let's say just input arrays for finding average. Alright, so first we'll have the argument, the happy path, which is this one. Or let's call it input values, just input values. Let's keep it simple. Input values. Right, so first we have our array, this array, and we expect to have 3.0 as the return type. Alright, and in order to do this we need to specify new integer to avoid errors. Here we'll have another new integer with a single number 10, and the average we expect to have 10. Alright, so this is a corner case, this is a happy path. Alright. Let's try to run this. So as you can see, they both passed the test. One more for our exception, which is a negative case. I will copy this one. We'll say user cannot get the average from integer array. This is not a valid array. We'll get rid of this since we have only one argument, which is an empty array from empty array. Alright. Then we're going to use assert throws. Assert throws. It's going to throw, let's see, no such element exception. So it throws no such element exception dot class. Then we have our lambda. We'll take this one and put inside our lambda. And we need to import the library. to an entry point test. Alright, let's run this. As you can see, user cannot get the average from empty array, which throw no such element exception. Could we actually avoid this double result? Could use return? Could we? No. We cannot. Can we just remove this? Yes. We could remove these as well. Like this. One more time. This is a more simplified version. Yes. Let's move to the next one. Convert a list of strings to a list of their lengths. Map to lengths. Let's go and create a new class. Map to lengths test, where we extend the methods test. Alright. We have our method map to lengths. It accepts a list of string and returns a list of integers. So we're gonna have tests for converting list of string for converting list of words into list of their lengths. Alright, so happy path. Happy path would be if we have this string Java C++ Go, and we obtain something like this. So Java 4, C++ 3, and Go 2. This is what we want. The corner case would be empty list. Empty list like this, where we obtain what? That's a good question. Probably maybe a list of 0 or empty list. I don't know, we'll check. Let's see what we got. So public void user can convert list of valid words into list of their lengths. Alright, so we expect to have a list of integers, right? So we'll call it actual list, okay? Then we'll use task dot map to lengths. list of these values. List of strings, actually no, we'll directly create new array list. New array list of these values. Alright. So now we use assert. Assert equals expected result would be this one. So I will just take this one and say new array list of these values. This is the expected one and this is the actual one. And let's put an annotation of test so that our compiler would know. Now we can run this. As you can see, it successfully passed the test. Now we have our corner case. What if it's an empty string, an empty list? So I will copy this one. So we will say user cannot convert list of cannot convert empty list user cannot convert empty list. Alright, so this will be our empty list. Let's see if it returns an empty list, just to check. Or maybe 0. As you can see, we have an error. Let's see what we got. So yes, it returns an empty list if we pass an empty list. So it returns let me comment So let's move to the next one. Splitting lines into parts by separator. So let's create a new class. Split string test, and extend the methods test. Alright, so the goal here is to have tests for splitting the string. So we have a method that takes two strings, input and delimiter, and it splits them by the delimiter. So for example, if we have this string, Java, Python, C++, and they have comma, so they're separated by comma, then, so you can see the delimiter is comma, then it returns a string of these words separated by the comma. So we have a case for one word, empty, and this one. So, okay, let's try to test them. So we have tests for splitting strings into splitting words into an array of strings by delimiter. So happy path would be this case. So when we have Java, Python, and we have the comma, like this, we should have an array of Java, comma, Python, comma, C++. Corner case. If we have an empty string and have delimiter comma, then we should get an empty array. Like this. And if we have one word, like this one, and we have delimiter comma, then we should get that word like this. Alright, let's find out. So public void user can split words into and split valid words. Alright. So what do we have? We have an input of string. So string input, and we have an output of the list. Of course we have the delimiter as well. Delimiter. We have the delimiter, which is a character actually. Character. Delimiter. Is that right? They used a string. Doesn't matter. We can use string also. Input delimiter and what? Expected result. So we expect to have a list of strings. So list of string expected result. Alright. So we have a list of string as an actual result, which is equal to task dot map. No, how do we call this? Split strings. Split string and use initial input. Use input and delimiter. Actually the return type is string, so that's why we're getting an error. So string, the expected output is also string, array of strings, like this. Alright, then we go and say assert equals expected to actual. Alright, now we make it parameterized test and specify the method source. I will copy paste since I have implemented this many times today. So valid strings for splitting. So happy path is when we have these two. So I will just copy this. These two, and we expect to have a string of these words. So we expect to have a string could we actually use just this one? No. So I think we need to have new string, this notation, in order to use this one. Let me copy this one. Alright, and we'll add it here as well. New string. So this is a happy path. Corner cases. So if we have a single word, then we should have that word. Alright. So what's the problem? So we have our arguments, happy path, corner cases. Now let's run the test. So they all failed. Expected. Let me try one more time. Assertion failed. Looks like we have an error here. For this specific example, we need to use assert array equals to equally check both string arrays. Now when we run this, we should get the correct results, as you can see. Alright. let's move to the next one. Checking the correctness of the password. So let's create a new class. We'll call it is valid password test, which again extends methods test. So for these ones we're gonna have a string of password and return type is boolean. So we're gonna have tests for checking if password is valid or not. Happy path. So for happy path, we have a condition. If password is null, then it's not a correct password. And if password length is less than 8, then it's also not correct password. So anything that has a length greater than 8 and it's not null will return true. So let's take this password. This should be true. Then we'll say corner case these ones are false. All right. Actually, there is one for negative case. This one is a negative case. Alright, let's go and implement this one. So public void user can check if password is valid. Alright. So for this one, I will directly use assert true. Assert true, so the expected result is true and the actual one is task dot is valid password and password 1. So this should return true. Let's run this. Yes, test passed. And one more, or two more for the false one. So we have test. Actually, this will be a parameterized test. So we'll use value source. We'll pass strings. So the first one is pass, which is not a valid password, and null. we cannot use null, I guess. Let's see. User cannot check if password is invalid. Okay, assert false. So here we'll have string passwords. Let's say password. Invalid password. Alright, let's try to run this. So we cannot have null, as you can see. Instead, what we can do is that we can have an empty string and let's have one more for our null. I will just copy this one, paste it here. User cannot have null password. Like this. So this should be false. Let's run this one. As you can see, user cannot have null password. User cannot check if password is valid. For these ones, so yes, that is it. Now we move to the next one. So we have the GCD, common greatest divisor, greatest common divisor. So these are the cases. We'll create GCD test. Let's create new class GCD test. Extends methods test. So what do we have? We have two integers a and b, and it should return its GCD. So we have tests for checking the GCD of a number, of two numbers. Alright, so what is happy path? So these are the positive cases. And we have a corner case here. Corner case. let's go and implement the public void user can check GCD of two valid numbers. Alright, so what do? We need to pass two valid numbers. So we use integer a, actually let's use num1, integer num2, and integer expected num. Alright, then we'll have integer actual num, where we'll use task gcd num1 num2, and we'll say assert equals first comes the expected, then actual. Now we need to parameterize this one. Use the annotation parameterize test and specify the method source. Alright. We can paste the stream. Where's my stream? So we have this input 24, 36, 12. So 24, 36, 12, 101, 103, 1, 101, 103, 1. These are the positive cases. And for a corner case, we will have 10, 0, 10. 0, 10, 10. Alright, then I will take this name and paste it to the method source. Now let's run this test. As you can see, they all passed the test. Let's move to the next one. We have to check if a string is a JSON object. So let's create a new class. Is valid JSON test. Again, we extend method test. And we have these test cases that we need to test. So this class is about tests for checking whether a string is a JSON file. JSON object. Alright, so what test cases do we have? So this is a corner case. Corner case. This is a happy path. And we have a negative case. Let's go and implement the method. So we have public void user can so let's say how can we name this? JSON validation. Okay, let's say JSON validation. Then we have what? We have let's put the annotation test, JSON validation. Then we will have, so the return type is boolean and it accepts a string. So what we're gonna do, we're gonna take this string, this is our happy path, and we'll say assert true. The expected one is this string, and the actual one is task dot is valid JSON actually we need to pass this one inside the method, and it should return true. That's our expected value. So expected value is true because we're using the assert true method, and the actual value will be after the execution of this method. So let's go and run this. We should get the green ticks, as you can see. It passed the test. Now we'll use parameterized test, and we'll use value source for the following methods. So public void how can we name this? Let's say, let me rename this. I will call valid JSON. This one will be invalid JSON. Alright. So we need to pass the string as initial value. Yes, initial value. Then we'll say assert false. Assert false. Task dot is valid JSON valid is valid JSON initial value, and the initial value will be passed using the value source. So we want to pass strings. So first we'll invalid JSON string that we specified earlier, and null. We cannot pass null. Okay, then let me change this one into the following. So this will not be parameterized. This will be a simple test. Okay, it should return false. Alright. And now I will create another one. Null JSON. Let's run this. It should also return false. As you can see, it passed the test. Alright. Let's move to the last one. So we need to check if an array contains duplicates. We have this method that returns boolean. So let's create a new class. Has duplicates test. Yes. Which extends the methods test to create an instance of class methods. So our goal here is to test this method, which accepts an array of integers and returns a boolean. So if our array has duplicates, so this one has duplicates, it will return true. This does not have duplicates, so it will return false. An empty array also does not have duplicates, so it will return false. I will copy this one and paste in our has duplicates test. So we're testing, we have tests that checks, test for checking whether an array of ints has duplicates. Alright, so here we have some test cases. So obviously the last one is a corner case. This one is negative case. Actually, this is a positive case. Positive case. And the first one is negative case. Alright. Let's go and implement this. So we have public void user can check if valid int array has duplicates. So we'll say assert true if task dot has duplicates when we pass our array. So new integer, let's say 1, 2, 2, 3. So this should return true. Let's put the annotation test and run this. So this is true. Now let's create parameterized test for the rest of the test cases. So we'll say public void user cannot, or user can check if a valid integer array does not have duplicates. So what we'll do, we'll pass a value source. So integer array and then we'll say assert false task has duplicates array. Now we need to specify the value source. So value source ints Actually for this one we cannot use value source, since value source is for primitive data types only. We need to use method source one more time. Method source. So I need to create public static stream of arguments, and I will say valid input, valid input, okay, and we'll return stream of arguments of the arrays. So first I will put new integer array without duplicates. So 1, 2, 3, 4, 5. Then we'll copy this one, and then we'll pass an empty array. And we need to explicitly specify that this is a false, and this one is false as well. So I will copy the name and paste it here. Now we can run this. So as you can see, it passed the test. So this was the last one for today. Thank you for watching, and I'll see you in the next one.